Alright, so I'm going to try and record some momentum problems for you. I'm going to start with number 15. A firework is moving at a speed of 50 meters per second. The firework explodes, but I think it has your x-axis kind of angled. And it splits into two pieces. Those two pieces have equal mass, so this one's going to be 1/2 the total mass. I'm going to call this one big M. This one's going to have 1/2 the total mass. I'm going to call this one B1, and this one's going to be B2 prime. We'll just call this M. And big old M is moving at 50 meters per second. And if I look at the diagram that I gave you in the problems, this angle is 30 and this angle is 60. So I need a 30 here and a 60 here. Well, if I go back and look at it, this chunk I'm calling M1 has this going on and this going on after the collision. So that's going to be B1x prime, B2x prime, and then this one right here has that going on, so that's going to be V2x. Oh gosh, can I go back to bed? Let's check this one out again. This one should have been B1y prime. That's B2x prime, and that's B2y prime. So I think I got them drawn correctly, finally. So on the y-axis, if you will notice, there is no motion on the y-axis prior to the collision, so this whole side is 0. Nothing's going on. So this will be M1 B1y prime plus M2 B2y prime. This one should be negative because it's going down, so I'm going to change this from a positive to a minus sign to show that this is a negative quantity. Bring it over to the left-hand side, it becomes positive. M2 B2y prime equals M1 B1y prime. M1 and M2 are both equal to each other, so this is going to be the sine of 60 B2 prime has to equal the sine of 30 B1 prime. Sine of 30 is 1/2. Divide both sides by the sine of 30, and I get 1.732 B2 prime equals B1 prime. This value came from dividing sine of 60 by sine of 30. Punch it in your calculator, you should get 1.732. Okay, now I want to go down over to this side and do the x-axis, so I can wrap this problem up. So I have M1 B1x plus M2 B2x equals M1 B1 x prime plus M2 B2 x prime. This is 0 because that didn't exist before. I'm going to call this side, instead of M1, it'd be better if I called it capital M because that's the total that I started with. So I have capital M times 50 meters per second is equal to, well, M1 is 1/2 of capital M, and B1x prime is going to be the cosine of 30 times V1 prime plus 1/2 big M cosine of 60 B2 prime. The big M's will cancel. So now I have 50. Alright, the cosine of 30 is 0.866. Half of 0.866 is 0.433. Get your calculator and check me. Cosine of 60 is 1/2. Half of 1/2 is 1/4. Now there's a problem. V1 prime is really the same thing as 1.732 V2 prime. So I got to put that in for this B1 prime here. So 50 is equal to 0.433 times 1.732 B2 prime. That was a substitution I made, plus 0.25 B2 prime. This quantity is 0.75 B2 prime. This quantity is 0.25, and that's 50 meters per second. So if you look at that, when you add up those two, you get 1. So B2 prime is basically 50 meters per second. B1 prime is going to be 1.732 times B2 prime, and that gives me 86.6 meters per second for B2 prime. And I have finally finished number 15. Alright, let's look at 16. 16 is very similar. You have a puck A. Mass of A is 0.25 kilograms. It's moving to the right at 5.5 meters per second. That's your VA. Hits puck B. Puck B has a mass of 0.05 kilograms. It's not moving. After the collision, puck A goes off like that, and puck B comes down like that. Puck B, puck A. This angle is 65 degrees. This angle is 37 degrees. Alright, they want me to find BA prime and BB prime. Well, if you look at it, BA prime is really made up of this and this, BY prime and BX prime, and that angle is 65. If you look at puck B, it's headed down. It has an X component here and a Y component. And this angle here is 37. Okay. Now, before the collision, nothing is going on the y-axis. So I'm going to work with that one first because that gives me a way to represent the two velocities. So I have MA BA y plus MB BB y equals MA BA y prime plus MB negative BB y prime. And it's negative because it's headed to the south. Those are both, oops, shouldn't have scratched that one out. Let me fix that. Actually, that was right. MA BA y prime. Nobody's moving on the y-axis. So I'm going to bring this over. So I'm going to have MB BB y prime is equal to MA BA y prime. So I know that this is 0.050 kilograms, and this is going to be the cosine. Oop, let me fix that. Sorry. This is going to be the sine of 37. This one is 0.025. This is going to be the sine of 65. Alright, so this will cancel and make that be a 2. The sine of 37 is 0.6. 0.6 times 2 is 1.2. BB prime is equal to, so now I need to punch in the sine of 65, so let's get that done. Alright, sine of 65 is 0.9063. So that's going to be 0.9063 BA prime. I'm going to divide both sides by 1.2. Cancel those out. So now I need to divide that by 1.2. And I get 0.755, 0.755. Alright, so that helped me. Now I need to go back and do the x-axis. So now I have MABA x prime plus MB VB x prime. Oh, these are not primes. So that equals MABA x prime plus MB VB x prime. This is 0. This is my 0.025 kilograms, moving at 5.5 meters per second, is equal to 0.025 kilograms. Moving at, okay, this is going to be the cosine of 65 times VA prime, plus the mass of B is 0.050 kilograms, and it's going to be times the cosine of 37. And then instead of putting in VB prime, I'm going to put in 0.755 BA prime. So now I got to plug some things into the calculator. So 0.025 times the cosine of 65 gives me 0.0106, 0.0106 VA prime plus, alright, so let's see if this one works. 0.050 times the cosine of 37 is 0.8, 0.04, so that's 0.04, and I need to multiply that by 0.755 times 0.755, and I get 0.0302. So I'm going to go back and make that be 0.0302 VA prime. And that has to equal 0.025 times 5.5. And I got 0.1375 right there. 0.1375. Alright, so I'm going to add 0.0106 and 0.0302. Divide both sides by 0.0408. So those will cancel. So now if I take my 0.1375 and divide it by 0.0408, I'm going to get 3.37, which works. So VA prime is 3.37, and VB prime is going to be 0.075. Can't seem to write this morning. 0.755 times 3.37, And that, I believe, is 2.55. Yep, 2.55 meters per second. And we are done with 15 and 16. I will move on to the next ones.